In problem number 11, we're asked to find how many inflection points this graph has over the ruled line. So if we're trying to find inflection points, we need to talk about the second derivative, so we need to get there. So first, let's do the first derivative, g prime of x. We're just going to be using our power rule on each term. If we bring down the 5, this would be 15 x to the fourth. Here we bring down the 4, we get minus 40 x cubed. And we bring down the 3 here, plus 30 x squared. So that's our first derivative, but we need to get the second derivative. So let's do it again. Again, using our power rule, we would get 60 x cubed. We get minus 3 times 40 is 120 x squared. And we get plus 60 x. So here's our second derivative by just using the power rule for each term. So if we want to find inflection points, we need to know where this is 0 or undefined. Now this is a polynomial, so it's not going to be undefined. We only need to find where it's 0. So we want to set this second derivative equal to 0. In order to solve that, we're going to need to factor this. And what you should be able to see here is that we have 60, 120, and 60. So we have a common factor of 60, and these all also have at least one x. So I'm going to factor out 60x, and let's see what we have left. It's going to be x squared. If we took 60 out of 120, we'd have just minus 2 left. And again, just 1x because we took out an x. X squared minus 2x plus 1. That can be factored even further because that's just x minus 1 times x minus 1. In other words, x minus 1 squared. So now that we have this as factored as possible, we can solve this pretty easily. Where could this be 0? Well, if x was 0, this would be 0, or if x was 1. So on our number line for second derivative, we're checking 0 and 1. So keep in mind, it's not enough to just say, well, the second derivative is 0 at 0 and 1, so those must be inflection points. That's not true. It has to change sign to be an inflection point. So let's see what happens when we plug in our numbers. So first, let's plug in something negative, less than 0. This would be negative. This term, x minus 1 squared, always positive, so we don't have to check that. We just get a negative value. So on both sides of 0 then, this would be positive. This is always positive. So everything else here is positive. Sorry, I meant on both sides of 1 that are positive numbers. So that's our sign chart for this second derivative. Well, you can see here, 0 is clearly an inflection point because it changes sign. But 1 is not an inflection point. So even though it made the second derivative equal to 0, it's not an inflection point because we didn't change sign on either side of 1. So therefore, the correct answer here is there's 1 inflection point, x equals 0, for this function. Again, always got to make sure you check the number line for the second derivative to prove something's an inflection point.
The Teaching Center, UF's Learning Resource Center.